In this video, we're going to solve a number of trig intervals. But first we need to have some identities to do so. For example, sine squared of x is 1 minus cosine of 2x over 2. The cosine squared of x is 1 plus cosine of 2x over 2, and the good old sine squared x plus cosine squared x equals 1. If we divide both sides by cosine squared x, we will get tangent squared x plus 1 is secant squared x, and if we divide it in this equation both sides by sine squared x, we get 1 plus cotangent squared x is equal to cosecant squared x. So those are really good identities to know to do these trig integrals. Suppose you were given this integral. The integral of cosine to the fifth x times sine x dx. Well, if you just let u equal cosine of x, well then du will be negative sine x dx. If you sneak the minus sign in, you have du, but you have to counter that by putting a negative in front of the integral. There's the negative in front. Now this is u to the fifth. This here is u to the fifth times that, which is du. Couldn't be any easier at this point. Add 1 to the exponent, divide by that exponent, plus c. So it's negative whatever u is to the sixth over 6 plus c. And do bother to look to see what u is. Don't try to remember. So it turns out we could have written the answer this way. Now, suppose you have the integral of sine to the fifth x times cosine squared x dx. Now, you have to understand that since this is an odd power, you can break off 1 sine x. When you multiply it by the dx, you want that to be du. Again, if you need 5 sine x dx or negative sine x dx, you can get that constant. So since I broke off 1 from the 5, I still have 4 remaining. And I have the cosine squared x. Okay. Now, we know that sine squared x plus cosine squared x is 1. So if I bring this over to the other side as cosine squared x, it's no longer on the left side. So now I have a way of converting sine squared x's to cosine x's. And then I'll have cosine x's times the other cosine x's. I'll have cosine x's to exponents. But there's my du. Maybe I'll need a plus minus sign. Okay, so let's do this. Sine to the fourth x, well, that's sine squared x squared. Let's do it in a couple of steps. And we're safeguarding the sine x dx. So sine squared x is 1 minus cosine squared x squared. That's this squared times cosine squared x times sine x dx. I'm going to FOIL this out. Like I said, I'm going to end up with powers of cosine x's times cosine squared x. I'm going to get 1 minus 2 cosine squared x plus cosine squared x squared, which is going to be to the 4th, times cosine squared x times sine x dx. Okay, distributing this cosine x, I get cosine squared x minus 2 cosine to the 4th x plus cosine to the 6x times sine x dx. Now, if I call cosine x u here, and I call u cosine x there, and I let u be cosine x here, okay, if u is cosine x, well then du will be negative sine x dx. So I'm going to sneak in the minus sign, and I'm going to have to bring a minus out in front. Now there's a minus in front. So this is u squared minus 2u to the 4th plus u to the 6th times du. In fact, let me distribute the minus in front. Here we get negative u squared plus 2u to the 4th minus u to the 6th du. This pretty simple integral. It's negative u to the 3 over 3 plus 2, add 1 to the power, divide by the power minus, add 1 to the power, divide by that power, plus c. And we'll substitute back in what u is. So we get negative u cubed. So you get cosine cubed x over 3 plus 2 u to the 5th over 5 minus u to the 7th over 7 plus an arbitrary constant. And that finishes that problem. Having that odd sine x, power of sine x, was helpful. Well, what if we have the integral of sine squared x times cosine cube x? Well, this time the odd power was cosine x, or is cosine x. So I'm going to break off one of the 3. So there's the 2, and I'm breaking 1 off for my du. And I want to write everything else as u to powers, or sine x to powers. Because if u is sine x, there's my du. So what I'm going to do is, well, I have that, sine to a power. I need to write cosine squared as 1 minus sine squared x, cosine x dx. Don't mess with that du. Distributing, I get sine squared x minus sine to the 4th x times cosine x dx. Well, if I let u be sine x, well then du is what I've been saying it is cosine x dx. What we have is u squared minus u to the 4th times this, which is du. So we get u to the 3 over 3 minus u to the 5 over 5 plus c. But u is really sine x. So I get sine x cubed over 3 minus u, which is sine x to the 5th over 5, plus an arbitrary constant. If you were asked to compute the integral of sine squared x, you can always say, well, it's sine squared x is 1 minus cosine squared x, which is not wrong. And I can integrate 1, but what's this integral? This integral is no better than that integral. I can say that I can break off for sine x and don't touch it. Hopefully that's my du. But if this is du, then that's not u. Only because if u is sine x, du would be cosine x dx. So that's not working. And then we say, oh yeah. We put some substitutions at the top. Sine squared of u is just that. Is 1 minus cosine 2x. Is 1 minus cosine 2x over 2. So we integrate that. And to not be confused, let's factor out the 1/2. So we have 1/2. The integral of 1 dx is x. The integral of cosine 2x, well, let's take, it's going to be plus minus that, what I just wrote, with maybe a constant wrong. The derivative of this is cosine 2x times 2. So I got the cosine 2x. I just don't want the times 2. But I will have it when I take the derivative of sine 2x. So I'll divide by 2 and it'll get canceled out. And here is your answer. You know, if you like, you can double this and that, and then you can factor out a quarter. And you'll have 2x minus sine 2x plus c, or 2x minus sine 2x all over 4. Any one of those three answers should be acceptable, especially these two at the bottom. If you're gonna leave the one above, then don't write the 2 over 2. Okay, that finishes that integral. Suppose we have the integral of secant cube x times tangent x dx. So, if we break off a secant x from here, what will be left over is the other secant x times the tan x times the dx. And that's what we're going to hold on to, because if I let u equal secant x, well then du is this. It's secant x tangent x dx. So I have u squared times this, which is du. Oh, that's easy. That's u cubed over 3. Not saying this problem was easy. I'm saying once you get here, it's easy. That's why we do trig substitutions. u is secant x cubed plus c. So of course, you can write the answer that way. That is your answer. We broke off from the secant cube. We broke off for secant, hooked it up with the tangent x dx, and then we had secant to our power. But the derivative of secant, or the differential of secant, is sitting right here. Jump on that. In fact, if you have the integral or secant to the mx times tangent x dx, you should break off for secant x. So you'll have m minus 1 of them times the one that you just broke off times the tan x dx that's there. Now, if you let u equal secant x, well then du is secant x tangent x dx. Secant x tangent x dx. So that's du, and this here is u to the m minus 1. So let's assume that m is not 0. Let's assume that m is not 0. Because if m is 0, then this is u to the negative 1 du, which is an ln. So what you get is u to the m minus 1 du. You add 1 to the power. You divide by that power plus c. And u is secant u to the m over m plus c. And there is your answer. Now, what if m is 0? What if m is 0? That is, if you have just the integral of tan x dx, you can say, wait a minute, you know what? I want to multiply by secant x. There it is. But I have to counter by multiplying by secant x to the negative 1. So if I let u equal secant x, then du is secant x dx. Oops, secant x tangent x dx. Okay. Now, I could put this secant on the bottom. So I have u on the bottom, I have du on top. This is just ln of u. Don't ask me why I wrote dx. It's ln of u plus c. Now, to be honest, I would never integrate it this way. I just wanted to illustrate what happened is if you think of having secant to the 0, which is 1. How would I do such an integral? I would realize that tangent x is sine x over cosine x dx. And if I call this u, so I have a u on the bottom, if I snuck in a minus sign, then that would be du. But of course I need to bring out a minus sign. So I get negative ln of u. U is cosine x. But this negative 1 can go as the power. So I get ln of cosine x to the negative 1. But cosine x to the negative 1 is secant x plus c. So in the end, I do get the same answer. Now, suppose you have the integral of an odd power of secant x dx. Okay, so there's a slight typo in this integral. It should be secant to the 7x times tangent x dx. The derivative of secant x is secant x dx. So it doesn't even matter what that power really is, whether it's odd or not. I can still break off 1. So I'll have secant to the 6x times the secant x I broke off times the tan x dx that has always been there. So if I call this u, well then that's du. That is, this whole piece will be u to the 6 times du. Well, that's just u to the 7 over 7 plus c. U is secant x to the 7th power over 7 plus c. So that took care of that one. Now, suppose you have this integral. The secant to the 4th x times tangent cube x dx. I can write the secants in terms of tangents. I can write the tangents in terms of secants. The question is, which is the best way of doing this? Now, if I were to break that up into tangents, secant squares powers of that. Since it's an odd power, I'll still have one tangent left over. And then I realize I'll always have another secant to link up with that lone tangent. Tangent x dx. So let me do that right away. I'm going to break off one secant. So I'll have secant cube x times tangent squared x times the broken off secant x times the tangent x dx. Now I can write this in terms of in terms of secant x's, and when I multiply it by that secant cube x's, I'll get secant x's to powers. And the du will be right there. I'll have u to powers times du. So what I do is I recognize that tangent squared x is, you have to know these rules on the top, tangent squared x is secant squared x minus 1. Secant squared x minus 1 times what I'm going to call du. And it's going to work out like a charm, because when I distribute, I'm going to get powers of secant. Secant to the 5th x minus secant cube x. And again, if I call secant x du, then what's left over is du. So if this is u, and that's u, and that's du, well then I have u to the 5th times du minus this integral. Minus integral of u cubed du. Well, this is just u to the 6th over 6 minus u to the 4 over 4 plus a c. And I substitute back in secant for u. Secant x to the 6th over 6 minus secant x to the 4th over 4 plus a constant. And it worked out perfectly. Now, let us look at this next one. Suppose you have the integral of x times sine squared x. Now, this clearly dx. This clearly looks like an integration by parts problem. And remember that sine squared x is nothing more than 1 minus cosine 2x over 2. So we have derivatives, we have integrals. X, 1, 0. So I got to 0. Question is can I integrate sine squared x twice? Well, integrating this is the same as integrating that. The integral of 1 minus cosine 2x over 2, I'll bring the half out, dx. There's the half. The integral of 1 dx is x minus the integral of sine 2x is negative sine 2x over 2. So I get 1/2 x plus sine 2x over 2. Okay. What's the integral of that? Well, the constant stays. The integral of x is x squared over 2 plus over 2. What is the integral of sine 2x dx? Well, it's going to be negative cosine 2x, because the integral of sine of u is negative cosine u. And if that's u, I have to sneak in a 2 and bring out a half. So I sine u du, and I'm going to get negative cosine u over 2. Okay, so I get negative cosine of 2x over 2. So it turns out that the denominators are 4. And there's my answer. Is plus that product minus that product. So it's 1/2 times x squared plus x sine 2x over 2. I distributed the x minus, well, 1 times this is just this. X squared over 4 minus cosine 2x over 4. So we have half x squared, and we're taking away 1/4 x squared. So we have 1/4 x squared left over. And we are adding on x sine 2x over 4. And minus minus means plus. So we're adding on cosine 2x over 4 plus a c. Okay. Now, let us try this last one. Last one's going to be not trivial, in my opinion. Suppose you have secant to the 4th x dx. Now, you kind of get stuck here. So maybe you'll convert to tangents. So secant to the fourth x is secant squared x squared dx. But secant squared x is tangent squared x plus 1 squared dx. And when we square this, we get tangents to the fourth x plus 2 tangent squared x plus 1 dx. That is, we get the integral of tangents to the fourth x dx plus 2 times the integral of tangent squared x plus the integral of 1 dx. So let us try to figure out how to handle this first integral. Okay, so the integral of tangent to the fourth x dx, well, this is equal to tangent squared x times another tangent squared x. But I'll write that tangent squared x as secant squared x minus 1 dx. Let us see what happens here. If we distribute, we get tan squared x secant squared x minus tangent squared x dx. Now remember, the derivative of tangent is secant squared x dx. So the integral of tangent squared x secant squared x dx, this integral, if I let u equal tangent x, then du is secant x dx. That is, that's du, and this is u squared. We have u squared du. This is u cubed over 3 plus c. This here is tangent cubed x over 3 minus the integral of tan squared x. Okay, so let's just come up here for a moment. So this integral is what I have at the very bottom. Tangent cubed x over 3 minus one of those tangent squares. But then I'm adding 2 more. So I'm just really adding 1 tangent squared x dx. And while we're at it, the integral of 1 dx is x. So now we need to figure out what tangent squared x is. Okay, so let me do that below. The integral of tangent squared x dx, well, that's the same as tangent squared x is the same as secant squared x minus 1 dx. Well, I know the integral of secant squared x is tangent x minus, and I know the integral of 1 dx, it's x. So it's tan x minus x. So I erase this and I put tangent x minus x. And the minus x and the plus x go by. So I'm left with this. Tangent cubed x over 3 plus tangent x. Remember, the minus x and the plus x canceled out. So there is your answer. And this completes the section on trig integrals.